How are you? Looking good today. All right, let's go ahead and we're going to jump into chapter 8 today. Now, let me kind of remind you what's happening here with the class over the next couple of weeks. One is next week you're not going to think about class, okay? So you need to relax. You need to enjoy your break. If you're going somewhere, that's fantastic. Have fun. Be careful. If you're staying here and working or whatever, then just make the most money possible, okay? Because it's your week. We're going to finish up chapter 8 probably Thursday. Now, on last Thursday, what I did is I posted a Tegrity recording to Canvas, and you can find that now. It's in a little different place, so if you go to the Tegrity recordings on your course homepage, what you're going to find is, if you go to, now most of the recordings are here, okay, but if you go to additional content, you'll see it here, chapter 8, part 1 of 3, and now, even though it was recorded, I think it was recorded last spring maybe, you'll hear some of the dates referred to. You don't necessarily have to pay attention to that, but it's kind of strange that we actually have the test over chapter 5 and 8 the Thursday after spring break, which is what we're doing this year too. So it just happened to work out that way. But again, you can find that. And as you are thinking about preparing for the test, what we're going to do is we'll finish chapter 8 Thursday. You'll have next week off. When you come back the Tuesday after spring break, we will review for test number 2, which again only covers 2 chapters, chapter 5 and chapter 8. And then your test will be on the Thursday after spring break. Okay? It'll be the same format, 50 questions, multiple choice. Since it's only over 2 chapters, of course, it will probably be a little more in-depth on each chapter than if we were covering more than that. But otherwise, a reminder, the career fair is this afternoon from 2 to 5 for any of you that plan on attending. That's the All Majors Career Fair. The STEM Career Fair is tomorrow from 2 to 5 if any of you plan on attending that. Are there any questions about, well, anything to this point before we jump into chapter 8? You guys are already in spring break mode, aren't you? I mean, it's freezing outside, but you are in spring break mode. Okay, I can't say that I blame you. All right. So I really hope this is recording today. If it's not recording today, then I will post another recording, pre-recorded lecture from chapter 8. Okay, now let me just kind of bring you up to, even though you can listen to the recording on chapter 8, the first recording, let me kind of bring you up to date on what we're doing here. Now, in chapter 5, it was time value of money. And time value of money is the most important topic that you're going to cover in any principles of finance course. Risk and return, which is chapter 8, is probably the second most important topic. Because, again, this is just a huge area of finance. Because if you look at any kind of finance, banking, investments, corporate finance, insurance, it's all about risk, managing risk, and also return. And so we're going to talk about how do you calculate return on an investment, and that's actually covered in the first video that I've already posted. We're going to look at ways to measure risk, because there in finance there's lots of ways to measure risk. There's lots of definitions of risk. I mean, that's what it's all about. So we're going to look at some I know this is a bad word for a lot of you, statistical methods for measuring risk. So if you loved your stat class, you're going to love this chapter. If you didn't like your stat class, I'm still going to make you try to like this chapter a little bit, okay? Because I'm actually going to show you how you can use some of the numbers that you talked about in statistics to help you with, if nothing else, if you decide to invest in the future, help you with your personal investing. And then if you decide to go into finance, of course, then it's going to be a benefit also. So, and again, this is covered in the first recording, so I'm just going to run through some of this, but I'm just going to point out some things as we go through. You've got a couple of definitions here, risk and return. We're going to talk about the risk of a single asset versus the risk of a portfolio. A portfolio is simply a group of investments or a group of assets. This is the formula for return. It looks a little messy, but it's not. It's really simple, and actually I'll go into, if you look at the first video posted, I'll go into an example of this. This formula will also be given to you on the second test on the formula sheet, so you don't have to worry about memorizing this. So there's the example that I discussed. This talks about investor risk preferences. We discussed this a little bit earlier in the semester when we talked about the term risk aversion, and I gave you the skydiving example of risk aversion, which said you have to be paid for taking additional risk. But there also are some investors that will be considered risk neutral, or a very small amount that will be considered risk seeking. And so again, that's discussed on the first video. There, we talked briefly about some risk assessment techniques. These are sort of what I would call non-technical techniques. So things like scenario analysis, the range of an investment. These are the two assets that we deal with in our examples throughout the chapter. So asset A and asset B. You can see the initial cost or the initial investment of each one, and then you can see the possible outcomes associated with each investment. And so we'll go through this. It talks about probability distribution in the first video. It talks about the distribution of this, which you can see here. And basically what we're looking at is when it comes to risk, the wider the possible range of outcomes, the riskier the asset. Because a lot of times what we think of when we think of risk is we think about maybe if we invest in an asset and we think we're going to earn 10% on that asset, but we earn less than that, we think of that as risk, the risk of earning less than what we expected. But also, so that would be anything to the left of our expected return. So anything this direction. But also, risk is anything more than we expected to earn also. So that would be anything to the right of the expected return. So if we look at these two assets, we could quickly determine that asset C is less risky than asset D because it has a narrower range of outcomes. Okay, so asset D we could earn, we look over here and we think, wow, we could earn up to 25% on asset D. Well, you could, but you could also earn only 5%. So there's a much wider range of outcomes. Now, this gets into the risk measurement, so the statistical aspects of this. And again, I know most of you have had a stat class. If you haven't, don't panic because we'll take this slow as we work through this. This part was already discussed, okay, but I'll just kind of go over it really quickly. It's talking about the standard deviation. That's one of the two risk measurement techniques. And it says standard deviation measures the dispersion around the expected value. In this case, it's the expected value of an investment or the expected return. And it's signified by our notation here, the lowercase sigma. Now, to calculate standard deviation, you first have to calculate expected return, which is going to be denoted here with our R with a line over it. I call this R bar. And so the expected return, and I go through this in the first video, is just the return of each possible outcome multiplied by the probability of that outcome occurring. So when we get into these formulas, they look a little messy, and you've got your summation signs and your in and all of this, but these are really easy, okay? You're just going to take your expected return times the probability for each possible occurrence and then add them together. So if you've got 3 possible outcomes, you would have 3 things to add together. If you've got 10 possible outcomes, you would have 10 items added together. And again, I go through an example of this on the first video. But you can see here, and this is in your book, where we're simply taking the probability times a return, coming up with what we call the weighted value. We add these together, and this is the expected return for each asset. So each asset has an expected return of 15%. Now, once we calculate the expected return, then we can calculate the standard deviation. So it looks even messier. But again, you're going to be given this formula, so you don't have to memorize it. And once you work one or two of these examples, you'll be an expert on calculating standard deviation. The reason that I go through this by hand in this class, because some of you are sitting there thinking, I can get on Excel and calculate standard deviation in about 5 seconds. And that's true, you can. But whenever you calculate standard deviation and you come up with a number, for example, 3.4%, 10.8%, whatever it might be, I want you to understand when you're highlighting the columns on Excel to calculate standard deviation, I want you to understand, what is that exactly telling me? Okay, what does that number mean to me? And so I think working through this by hand helps you understand better what that number actually represents. So what this says is, to calculate the standard deviation for an asset, we're going to take the return associated with an outcome minus the expected return, which we've already calculated for, and for our two examples in the book, it was 15%, 0.15, squared times the probability of that event occurring. So you're given this, you're given the probability. The only thing you really have to calculate, if you're not given it, is the expected return. And then we're going to simply do the multiplication and then add all of these together. So again, if you've got 3 outcomes, you'll have 3 things to add together. If you've got 10 outcomes, which I wouldn't give you that on the test, I'll give you a nice short one, so you don't have to spend 30 minutes calculating standard deviation. But you would just do the math, and then you would take the square root of the outcome. Because if you remember from statistics, if we have sigma squared, that represents variance. And so variance would simply be all of this without the radical. Okay? And the way we look at this is, the higher the standard deviation, the higher the risk. And that goes back to what we looked at earlier with the probability distribution, where we had a wider range of potential outcomes. So with this, now, and again, I'm still into what we talked about on the first video. This is in your textbook, and this is your textbook trying to explain the calculation of standard deviation. They do a decent job of it, but what confuses me a little bit as we go through this is they break it down in such small steps that I think sometimes students are more confused by this than they are helped. Because you can see, I mean, they're following, here's their formula here, R minus R bar squared times probability. So they've got, this is for asset A. So this is the expected, it's the return, this is the expected return that we calculate. If we take this minus R bar, we get negative 2%. Then we square it, so they're still following the formula here. The probability is there's a 25% probability of this event occurring. And they take the 4 times the probability. They come up with this. So we're still working through here. Once you do that for all 3, add these together. 1 plus 0 plus 1 is 2%, which they're doing down here. They take the square root, and that leaves us with a standard deviation of 1.41%. Okay, so what does that mean? Well, I'll explain that to you in just a minute. Now, for, again, this is how they do it. This is the same problem, but I went through and calculated this using the formula, because I think this is, once you do this once or twice, it's a little bit easier to understand. So this is the same thing that we had here, where we've got the return minus the expected return squared times the probability of that event occurring, plus the second possible return minus the expected return squared times the probability of that event occurring, plus the return minus the expected return squared times the probability. So if we do the math here, we're going to come up with this. And you'll notice they were using whole numbers here. I'm using decimals. Now, I would suggest it doesn't really matter which one you use, but if you use one, stick with one. So if you're going to use whole numbers, stick with the whole numbers. If you're going to use decimals, like I've done here, stick with decimals all the way through. Because if not, you get a little confused on, okay, where should my decimal point go on this? So work through this. This comes up with 0.0002. We take the square root of that, and it equals 0.0141 or 1.41%, which matches what we found here in the book's example. So again, it's just a standard deviation calculation. So nothing extremely complicated, I don't think, once you work through an example. All right, so are there questions to this point? That kind of brings us up to date on where the video stopped for the first one. So any questions? The week before spring break is not the time to cover the statistical chapter, okay? I know that. It's just, that's how it fell, so I can't do anything about it. All right, now this is for the calculation standard deviation for asset B. So what I want you to do, and I want you to take just a minute to do this, is, and I'm going to jump back here to, here's the formula, so you may want to write the formula down. If you don't have it memorized, I'm sure most of you don't have it memorized. So write the formula down. Then I will go back and take you back to the numbers that you're going to use. And I want you to take about 5 minutes and just work through a standard deviation calculation for asset B, just to make sure we're all good with that. And again, the order of calculation is really important here. So for example, you want to do your return minus the expected return squared times the probability. That is all one calculation. You need to do it in the proper order. So you're going to do what's in parentheses first, then you're going to square it, then you're going to multiply by the probability. That's going to give you one number, and then you're going to do this for each possible outcome. All right, so once you have the formula, let me go back and find. Okay, so here are the numbers that you can use. Now, we're going to do this for asset B, okay? This is a probability of each return occurring. So a 25% chance of a 7% return, 50% chance of a 15%, and 25% of chance of a 23% return. And this is your R bar. This is your expected return. So take the formula and this information for asset B, and again, take just a few minutes. You can help each other out with this. If you get confused or if you need me to help you, I would be happy to help you. But just run through this so I'll know that you are proficient at calculating standard deviation. It is, yeah. Yeah, it's just 0.15 is how you would write it. think, I mean, I guess, I'm not sure about the math there, but now this is all under the radical, so you'll need to take the square root of that. But yeah, the numbers are all in the right place.
Okay.
Okay, what I'm going to do is I'm going to go ahead and just start working on this because I don't have it worked out. But we'll take a look. Now this is for, let's change our red. All right. So our standard deviation, this is for asset B, is equal to, it's going to be the return, which let's see is 0.07 minus the expected return of 0.15 squared times the probability of 25% times 0.25 plus the second possible return minus the expected return squared times the probability of that event occurring, which is 0.50, plus the third possible return, which is 23%, minus the expected return of 0.15 squared times the probability of 0.25. And again, all of this is under the radical. So again, what you would do here is you would simply just start working the math. So we've got our brackets here, so we've got three different calculations. So 0.07 minus 0.15, 0.08 squared times 0.25, which is 0.0064, 0.0016, is that right? 0.0016 plus, I can do this one myself, 0. Plus point, so it's going to be the same thing, 0.0016. And again, this is all under the radical. So that's going to equal, if we add these two together, 0.0032. And if we take the square root of 0.0032, that is beyond my capabilities to do this in my head. So if you would, 0.0565, 0.0566. Or 5.66% equals the standard deviation for asset B. And we could compare that to 1.41%, which was the standard deviation for asset A. So if we're just looking at these two numbers, what we would say is that asset B is the riskier of the two because it has the higher standard deviation. So are there any questions about, I mean, as you can see as you were going through this calculation, I heard some of you talking, it's easy to make mistakes when you've got all of these numbers that you're dealing with and all these calculations. So for test purposes, I will give you a standard deviation calculation. It's going to be something similar to this, okay? Probably 3 possible outcomes. It's not going to be some marathon problem, okay, with 10 or 12 possible outcomes. So if you can do something like this, including calculating the expected return, you're going to be fine on the test. So are there any questions about these numbers, where these numbers came from? This should be 0.0016. And this should be 0.0016. And this is supposed to be a 6. Okay, now, when you took a stat class and you talked about, well, I'll just give you my experience with statistics, okay? When I took stat classes in college, all I can remember really talking about was, we talked a lot about flipping coins. We talked a lot about cards. We talked a lot about, let's see what else, coin flipping, cards, dice. We talked a lot about dice. We talked a lot about gambling. But nobody ever really said, okay, you can use what you're learning here to help you with whatever, your professional life, your personal life. I mean, nobody really connected that. So I want you to kind of, in here, hopefully take what we're doing here, which, we've got, for example, our standard deviation, but how can that help us when it comes to investing, for example? So I want to show you how that can help us. Now, has everybody finished copying this down? Now, if we find this. Okay, now this was, let me jump ahead here. This is for A. Okay, so this is in your book. This was for B, okay? So this is how they did it in your textbook, and they came out with 5.66%, which is what we found calculating ourselves, okay? Now, what this means is, you talked about in stats something called a normal probability distribution or a bell-shaped curve. And you probably spent a lot of time talking about this. And so what you learned in there was that if you had an expected return, then there was a 68% probability that an occurrence was going to fall within plus or minus 1 standard deviation. There was a 95% chance that occurrence was going to fall within plus or minus 2 standard deviations, and a 99% chance that it was going to fall within plus or minus 3 standard deviations. So based on this, and based on this normal probability distribution, and again, this is what you would have learned in class, then we can take, for example, what we learned with asset A. Let me go here. And remember that asset A's standard deviation was 1.41%. And the expected return was 15%. So the way we can use that is we can take our expected return, which was 15%, plus 1 standard deviation of 1.41, and that equals 16.41%. We can then take our expected return minus 1 standard deviation, and that's going to equal 13.59%. So based on the information, now we have to make some big assumptions here. One, we have to assume that stock returns have a normal probability distribution. There are other distributions. So we have to assume, for example, that it's not a binomial distribution. It is a normal bell-shaped curve. But if we think that's right, if we invest in this particular stock, then we have a 68% chance of earning between 13.59 and 16.41%. So basically, it's not exact, but we're using this as a confidence interval to help us determine what are we going to earn on this investment. We could do the same thing with plus or minus 2. So if we take the expected return plus 2 times the standard deviation, which is 2.82, that's going to equal 17.82%. And we could take the expected return minus 2 times the standard deviation, which is going to equal 12.18%. And there is a 95% chance we're going to earn between 12.18 and 17.82%. And we could do the same thing for 3 standard deviations. Okay, I'm not going to go through that calculation, but again, this shows you how standard deviation can actually be useful to you in terms of helping you determine how to invest your money. Now again, there's a lot of assumptions here, and of course it's statistics, and we can basically make statistics say whatever we want it to say. But it is a use other than rolling dice, flipping coins, drawing cards. Is some practical application of statistics. And I'll be the first to admit, when I was taking stat classes as an undergraduate student, I hated statistics. I did just what I had to do to get through it, thinking, I'm never going to use this again, so why should I bother learning it? So basically, I just skimmed over it, did what I had to do to make a decent grade, and left. Then I decided that I wanted to get a doctorate degree. And what I found really quickly was, in finance, especially as a PhD, you have to know a lot about statistics, because everything that I do when it comes to writing papers, I have to prove with various statistical tests. Nobody cares if I write a paper and I just give them my opinion of what I think is going to happen or what I think happened. I have to prove it statistically. Is it statistically significant? So that means that I had to take about 21 graduate hours of stat classes. And once I did that, I decided if I have to do this, I might as well learn it really well. And so I just sat down, kind of caught myself up on what I skipped through as an undergraduate, and then actually really learned statistics. So does that mean that I could teach your business stat class? Yeah, it does. Does that mean I want to teach a business stat class? Hell no, I don't want to teach a business stat class. Okay? I get enough confused looks in this class, okay? I don't want to have to teach stat. Is there a question? That's just if you go back to, that's just what basically, if we consider stocks have a normal distribution, then this is where you would expect an occurrence to fall. And this is just what you learn in a stat class. So there will be a 68% probability of it falling within plus or minus 1 standard deviation, 95% within plus or minus 2 standard deviations, and a 99% chance. So that's just given to you. All right, and then this is for asset B in case you wanted to take a look at it, and they work through the numbers here. All right. So that is standard deviation. Now, that's one way that we can measure risk. A second way that we can measure risk is something called the coefficient of variation, or the CV. Now, the great thing about it is it's a lot easier to calculate than standard deviation. The drawback is, if it's not given to you, you first have to calculate standard deviation. Because the formula is given to you here, it's simply the standard deviation of an asset divided by that asset's expected return. Really simple calculation. Now, notice that the coefficient of variation, the definitions here, it is a measure of relative dispersion. It's useful for comparing the risk of assets with different expected returns. So that's a key difference here. So if you don't have it in your notes, you want to add to standard deviation that the standard deviation is useful for comparing the risk of assets with the same expected returns. And it just so happened when we compared asset A and asset B, they had the same expected return, 15%. Now, in real life, that's probably not going to happen because most assets are going to have different expected returns. So based on that, we just can't look at the standard deviation because we're not comparing apples with apples. If one asset has a 15% expected return, another has a 4% expected return, we just can't look at the standard deviation. It's not going to give us an accurate measure of risk. But if we take the standard deviation of an asset and divide it by that asset's expected return, then what we're doing is we're basically standardizing our output, and we can look at the coefficient of variation. And again, just with standard deviation, the higher the coefficient of variation, the higher the risk level. And that's what it says here at the bottom. But again, it's a really simple calculation. Okay, you will need to know how to calculate this on the test, but you will be given the formula. Now, if you wanted to calculate the the coefficient of variation for asset A or asset B, we could do that here. So I just went ahead and calculated it. So this was for asset A, the standard deviation divided by the expected return gives us a coefficient of variation of 0.094. For asset B, it's 0.377. So again, just like with standard deviation, because they did have the same expected return, we would say that asset B is riskier than asset A. Now, one thing that I want to kind of warn you against as you are looking at these numbers, with standard deviation, we could use those percentages to help us calculate a confidence interval, just like we showed earlier. With the coefficient of variation, you can't do the same thing. Okay, so you can't, say plus or minus 1 coefficient of variation, plus or minus 2. What this tells us is, and you're not going to be asked this on the test, but I just want to explain it to you. This is a little beyond the scope of this class. What the coefficient of variation tells you is the units of risk per unit of return. So if we calculate a unit of return as 1 percentage point, or a 1% return, what this tells us is asset B has 0.377 units of risk per unit of return. Asset A has 0.094 units of risk per unit of return. So again, asset B would be riskier than asset A. And again, there's nothing wrong with risk. You just have to, as an investor, understand risk, and depending on your level of risk aversion, that's either a good investment for you or it's not a good investment for you. But it allows us to make that decision. All right, so those are ways to measure risk. Now, based on this, and we've been talking about a single asset, and that's a good way to start learning the material, is talking about the risk of a single asset. The problem with that is that in the real world, most investors own more than one asset. So, for example, a single asset could be that I just own stock, and it could be 100 shares of stock, but I just own stock in Walmart. So if something happens to Walmart and that stock price takes a big dive, I'm going to suffer as an investor. I'm going to take a big loss because I'm not adequately diversified, which we'll talk about that in just a minute. So what we're trying to do as investors is we're trying to create something called an efficient portfolio. So this is a portfolio of investments. So this is the definition of an efficient portfolio. It is a portfolio that maximizes return for a given level of risk, or minimizes risk for a given level of return. Once you write that down, you probably want to put a big star by it. That definition will be on the second test. But more importantly than just memorizing the definition, let me try to explain what this tells us. So it says a portfolio is a group of investments that maximizes return for a given level of risk. So it just makes sense that let's say that you're an investor and you decide that as an investor you can take a certain level of risk, whatever level that is. And we can measure it by standard deviation. We can measure it a variety of ways. But if you think that you can take, let's say, X amount of risk, doesn't it make sense that if you're going to put together a portfolio, you want to put together a portfolio of investment that maximizes the return that you receive for taking that particular level of risk? I mean, why would you want to put together a portfolio that provides you with less return for an equal amount of risk? It doesn't make sense. On the other hand, and again, this is just saying it another way, it's a portfolio that minimizes risk for a given level of return. So again, as an investor, let's say that you want to put together a portfolio that provides you a 10% annual return on your investments. So you're going to put together stocks, bonds, real estate, maybe gold or silver or diamonds or rental property, whatever. If you want a 10% rate of return, it makes sense. We want to put together the most efficient portfolio possible to give us that 10% return. So in this case, if we know the return, we're going to put together a portfolio of assets that gives us the minimum risk and also provides us with that 10% rate of return. That's the most efficient portfolio possible. Now, if you take an investments class, you'll look at something called an efficient frontier, and you'll go in and kind of, okay, you know, how do we do this and how it falls on the efficient frontier. That's not necessary for this class, okay? Just as long as you know the definition of an efficient portfolio, you're good. Now, this is another calculation. This is just a pretty simple calculation. It's a weighted average. We're not going to go into the risk of a portfolio. That gets pretty deep into some of the math involved. But you do need to calculate the return of a portfolio. And again, it's actually incredibly simple. The return of a portfolio, this is the actual formula, it's the weight of each asset times the return of each asset. So this is what we would do. We would take the percentage weight of asset 1 times the return of asset 1, plus the percentage weight of asset 2 times the return of asset 2. And you would do this for as many assets as you have in your portfolio. So all we're doing is multiplying and adding. No financial calculator inputs, you know, nothing complicated. And this is going to give us a weighted average return for our portfolio of investments. Now, the reason that this is helpful is because some investments that we have may be extremely risky. And they may make up a large portion or percentage of our portfolio. On the other hand, we may have some assets that are not very risky, and they make up a small percentage of our total dollar value of our portfolio. So the percentage weight is going to have a very large, how should I put this, a large effect on the overall return of your portfolio. So if we look at an example here, okay, and I just made these numbers up, but we've got 3 stocks here. We've got Ford, Facebook, and Apple Computer. This is our portfolio. We have $20,000 worth of Ford, we own $30,000 worth of Facebook, and we own $50,000 worth of Apple stock for a total of $100,000. This is our total investment portfolio. Now, sometimes you're given the percentage weight, sometimes you have to calculate the percentage weight. If you're not given the percentage weight, you would simply take the dollar value of the stock divided by the dollar value of the portfolio. So in this case, it would be 20,000 divided by 100,000, which is 0.2 or 20%. Ford makes up 20% of our portfolio. Facebook, 30,000 divided by 100,000, or 30%. And Apple, 50,000 divided by 100,000, which makes up 50% of our portfolio. And notice again, these weights have to add to 100%. And then these are the stock's expected returns. And again, I just made these numbers up. But it will show you that if we calculate the return of this portfolio, which again, following the formula, the weight times the return, the weight of Ford times the return of Ford, plus the weight of Facebook times the return of Facebook, plus the weight of Apple times the return of Apple. And we just do the calculations. You'll notice that our portfolio return is 17%. But also notice that Facebook and Apple both make up a 7.5% portion of the entire 17%. Now, you'll notice the reason is Facebook, even though we have a lower dollar value, it has a higher expected return. Apple, we own more of that, but it has a lower expected return. So that offsets each other, so they each have a 7.5% addition to the total return, which is 17%. So again, you will see one of these on the test. You can calculate the average return of a portfolio or the weighted average of a portfolio. You are good to go. Now, a couple of more statistical measures. One is correlation. Now, with this, you don't have any calculations, okay? But again, it's something you talked about in your stat class, and it's something that we can actually use in finance in terms of helping us understand the material. So it tells us here that correlation is a statistical measure of the relationship between any two series of numbers. And you would have talked in stat about positive correlation or negative correlation. Positive correlation simply means that those two series move together. Negative correlation means those two series move in different directions. The problem is, if we say that, and when we're talking about a series of numbers here in this chapter, and typically in finance, we're talking about stock returns. So if we say that two stocks' returns are positively correlated, that tells us they move in the same direction, but we don't know at what strength they move in the same direction. Do they move exactly the same every single day? Do they move somewhat the same on various days? Or if they're negatively correlated, again, it doesn't give us a measure of strength. So we can convert that into something called a correlation coefficient. And that's going to give us a nice standardized measure of the degree of correlation. And it's going to measure between negative 1.0 up to positive 1.0. Perfect positive correlation means the correlation coefficient is going to be a positive 1.0. Perfect negative correlation means the stock returns move in the exact opposite direction, and the correlation coefficient would be negative 1.0. So based on that information and based on understanding correlation and how stocks move together, and by the way, there's a lot of studies have been done on this. Most stocks move together with a positive correlation coefficient of about 0.65 to 0.75. What that means is, typically, stocks move together. So when one stock is up for the day, if you're looking at stock returns, if you go downstairs to the Financial Services Center, look at the big blue television screen, you're going to see if one stock's up, a lot of stocks typically are up for that day. Or if a stock is down, a lot of stocks are going to be in the red for that day. They're going to be down. And we'll actually take a look at that when we get to Chapter 7, and we look at exactly how to buy and sell stocks. I'll bring it up on a screen, a live screen, and you can watch the prices changing, and you're going to see either a lot of green or a lot of red. They're going to move together. But based on this is what we're talking about with perfect positive or negative correlation. This is an example of two stocks, stock N and stock M, that over time, you'll notice their returns, when one's up, the other's up. When one goes down, the other goes down, and it's by the exact same amount. So these two stocks are perfectly positively correlated. On the other hand, if we have something that looks like this, notice that when stock N is going down in value, stock M is going up in value. And then when stock N goes up, stock M goes down. So this is an example of perfect negative correlation. The thing is, in the real world, you don't see any of this. You don't see any of this. You're going to see something in between. And typically, you're going to see some low to medium positive correlation. Occasionally, you may see negative correlated stocks, but not very often, although that is actually good for your portfolio. Now, in taking a look at this, we can use the concept of diversification. Now, it says to reduce overall risk, it is best to diversify by combining or adding to your portfolio assets that have the lowest possible correlation. So that would be negative correlation or low positive correlation. Let me ask you an easier definition of diversification. And it's a saying you've probably heard. It has something to do with eggs, and it has something to do with a basket. What's that saying? Okay, don't put all your eggs in one basket. Now, the question is, can I put all my eggs in one basket? I mean, that's not as important as why did the chicken cross the road, but it's still a pretty important question to answer in life. What are you going to say? Okay, if I put all my eggs in one basket, and by the way, let me just take a poll. How many people in here have ever actually gone out to a chicken house, a chicken coop, and gathered eggs? Anybody in here? Wow, this is Okay, that's a few more than normal. I take this poll every semester. Okay, I have too. And I can remember as a little kid going over to my neighbor's house almost every day. You know, a little kid, and they've got 2 or 3 rows of hens, and so you know you're reaching up in there, and I was so little, you have to reach up in the nest and kind of feel around for the egg, praying that a chicken snake wasn't laying in there. So you're reaching around, you put your eggs. Now, if I happen to put all the eggs in one basket or one bowl, I've never seen anybody put eggs in a basket, but one bowl, and you're carrying them back to the house, and you happen to trip and fall, you're not having eggs that morning for breakfast. Okay? Now, that's an old saying, it's been around forever, but it has actually some practical use in finance. Because what we're trying to do here is we're trying to put together a portfolio that has all different types of stocks, all different industries represented, stocks that move different than other stocks or other industries. Now, some people would say, well, you know, if you invest in a mutual fund, and a mutual fund is simply a collection of, it could be stocks. If you invest in shares of a mutual fund, then you are diversified. Well, that's actually not true, because there are some mutual funds that only invest in certain industries or certain sectors within industries. For example, technology. If you invest in a technology-related mutual fund where it only buys the stock of technology-related stocks, those stocks tend to move together with a very strong positive correlation. So if one technology stock is down, all of the rest of the stocks in your mutual fund typically are going to be down. Or if one's up, the other is going to be up. So mutual funds, while they do provide diversification, you need to be careful and take a look at what type, and read the prospectus carefully, what type of stocks do those mutual funds invest in? Is it just technology? Is it just healthcare? Is it just real estate? Or do they invest in a variety of sectors across many different industries? Because that is diversification, okay? Now, when we look at this, basically what we're doing here is, here we've got asset F, asset G, and asset F and G. And what we're doing with this, let me bring this up, okay? Theirs is too neat. I can't use it. I've got to really draw something really ugly here. Okay, so we've got this, we've got this, and we've got this. Okay, so we had, I think, let's see, we had F, we had G, and this was time, this was time, and this was time. All right, so with asset F, I'm not sure exactly what it looked like. Let's see. Let's say our expected return looks something like this. And we can just say it's 8%. I don't know. This is our expected return. So with our investment, we had asset F, and it looks something maybe like this. So this is year 1. This is year 2. So let's say that we invested all of our money in just stock F, whatever that is. Well, you'll notice the first year, we expected to earn 8%, which is our horizontal line here. But we earned a lot more than 8%. We earned whatever this is. Maybe this is like 15%. So we're excited. But the difference between what we expected to earn and what we actually earned has a name. What do we call that? It's risk. That's the definition, and actually we didn't talk about that, but if you go back and listen to the first recording, that's going to be the first definition you talk about is risk. Now, the second year, we expected to earn 8%, but we earned less than that. We earned down here. Maybe that's, I don't know, 2%. But again, the difference between what we expected and what we actually earned is what we call risk. Now, most of us don't think of risk in terms of here because, again, we said we typically think of risk in terms of a negative context, like what we would see in year 2. In year 1, we earned more than we expected, but again, that's risk. Now, for asset G, let's say it looks exactly the opposite. So it looks something like this over time. So we've got year 1, we've got year 2. And again, we've got large amounts of risk. But what if, because we can see these are perfectly negatively correlated, or as close as I can draw it to that, what if we decided, hey, we talked about this in my Finance 330 class. So what if I take half of my money and invest in stock F, half of my money and invest in stock G? What would happen? Well, if we put together a portfolio of stock F and stock G, what you're going to see happen is you're going to see the expected return stay the same. There's no difference. We still expect to earn 8%. But what's going to happen to your returns over time is going to look something like this. Actually, it would be right on the horizontal line, but I'm drawing it off a little bit just to show you the time frame. Because these are perfectly negatively correlated, we can maintain our expected return, but our risk level basically goes to zero. No risk at all. And that fits the definition of an efficient portfolio that we talked about earlier. Now, this is similar to, I've got some different sports examples I use. Since I'll use a baseball example. Okay. In baseball, you have home run hitters, which everybody likes to see the home run hitter. Pretty impressive. But home run hitters also typically do what a lot? They'll hit a home run. They strike out a lot. Okay. And again, home runs are exciting. I mean, that's, you think about, wow, I would love to be a home run hitter. But what we're trying to do here, as strange as it sounds, is we're trying to stay away as investors from the big home run years. Because again, a home run year is fantastic, but those strikeout years really, really hurt your portfolio's return. What we want as investors is we want to be just a contact hitter. We want to be a singles hitter. We want to get up to the plate, slap the ball all around the field, get on base. That's that nice, steady 6, 7, 8, 9% return each year with our portfolio. And as we saw back in Chapter 5, if you can maintain that for 15, 20, 30 years, it's going to mean you're going to have a lot of money. The reason we want to stay away from these big home run years is, let's say, for example, you start off with $100 to invest. And the first year, you invest all of your money in a stock. It's a strikeout year. You lose, it has a negative 50% return. Okay? Negative 50%. So now your $100 is worth $50. And let's say the next year or years later, you want to get back just to your original starting amount. What percentage return do you have to make 50 into 100? You have to have a positive 100% return just to get back to where you started. And I can tell you a positive 100% return could take 2 years, 5 years, 7 years, 8 years. So you might waste 8 or 10 years, and your total return for this 8-year period is what percentage? You started with 100. You ended with 100. How much have you made? You have a big, fat 0% return over an extended 5, 6, 7, 8-year period. That's not going to get you to that $1 million that you want in your retirement account. So that's why we want to stay away from those. I mean, if every year could be a home run year, that's fantastic. The problem is that's not going to happen. It's never happened for anybody. It's not going to happen for you. I don't care how smart you are. So let me just go ahead and burst that bubble right now. You want those nice, steady investment years. All right. Any questions about what we've covered so far in Chapter 8 before I set you free from statistics for today? The test of what chapters? Chapter 5 and Chapter 8. Okay. So, on Thursday, we will finish Chapter 8. When you get back from spring break, that Tuesday, we will review for the test over 2 chapters, Chapter 5 and Chapter 8. And then on that Thursday, you will have your second test. So, everybody have a great day. I will see you on Thursday. Don't forget about the career fair this afternoon.